Alright, so one of the things that we're going to want to do for our movement is use relative changes to our velocity rather than setting our velocity each time. And this is a little more advanced movement system that we've had previously, so let's have a look and see how we might do something like that. In our player movement script at the moment, in our fixed update method, we are taking the velocity of the rigid body and then assigning it a value, which is the value of moving left in this case and the value of moving right in this case. But whenever our object falls through the air, we don't want to change the value of its velocity, which is the y value of that velocity going up and down. And we also want to reset our velocity whenever we're not inputting either A or D to move left or right. And that way our object will stop moving in that direction whenever we stop pressing the key in that direction. In this case, what we're going to use is a variable which we can reset every frame and therefore be able to add our relative movement to that vector3 variable and then apply that to the velocity. And that's perhaps a very abstract concept, so let's just go through it and we'll see how it works. So let's say this is new velocity. So we've created this new variable. It's another vector3. Vector3 is everywhere. This one's called new velocity. And instead of assigning our value to the velocity directly at once, we're instead going to assign it to this variable temporarily. Now, at the moment, whenever we set this value based on pressing the A button, we're also checking if this is the D button as well. Instead of assigning it directly, we're going to instead add to it by using this plus equals. That means that each of these changes won't override the previous change, but we do want it to reset every frame. So first of all, we're going to set it to a zeroed out value. In this case, we'll need a new variable, which is called perhaps like zero velocity. So we'll set it to 0 every frame to start with. So first we set it to 0. Now we're adding to it with the left direction if we're going left. We're also adding it on the right if it goes right. In this way, whenever we save and run the game, whenever we're not pressing left or right, our new velocity will just be 0. Now there's one problem with this. There it goes. The problem is that we're not actually assigning it to the rigid body. We've just saved it in our own custom variable. So the last thing we need to do every frame is grab that velocity again, rigid body dot velocity, and set it to our new velocity that we're keeping track of at the end of each frame. So I'm going to save this out and run the game. Now our object is moving very, very slowly. Why might that be? Well, that is because we keep on setting the velocity to 0 if we are not moving left or right. But actually when we are falling, well, the object, we want it to have a y-axis velocity. So we don't actually want to set the velocity to 0. We only want to set the x and the y-axis value to 0. Instead of setting its velocity to this value, what we actually want to do is set it to 0, but then override its y value with the value it already had. That means that we're setting our value to 0, then we're retaining the y-axis of its velocity before setting the velocity back to our new variable, which means that our y value of falling and going up and down or jumping in the future won't be affected by our relative velocity movement. Let's have a look and see how that works. Looks good to me. Whenever we move across the screen, we can see we fall relatively effectively. I'm going to go ahead and just tweak these values again. Instead of 40, I'm going to go ahead and choose 70. In this case, we're just increasing the amount that we move by. So we move just slightly faster. So finally, we're going to want to add to our movement the ability to jump. In this case, we're going to add another if statement. So I'm going to copy and paste this. You might see where this is going. This one is going to be a space instead of D and A. In this case, we're saying if we press the space button, what happens? And what we want to do is add a large boost to our velocity. In this case, our up direction, which we don't have yet. So we'll make it up here. Public vector 3. I'm doing a lot of copy and pasting because I'm very lazy and I don't like typing out the same thing over and over again. In this case, public vector 3 up direction, which will be the direction of moving up whenever we jump. And this time we're not going to use our delta time because we don't want this to happen over and over again every frame. We only want it to be one initial burst of upward velocity. So we're going to go ahead and instead change our get key to get key down. And this means that we'll not jump as we hold the button down. We'll only jump the once when we press it. So we can move left and right, but we're not jumping. What might we have forgotten to do? Well, we've set our left direction to -70, we've set our right direction to 70, but our up direction is 0, 0, 0, which is no good. We want our up direction to be going up, and we can see that means going up on the y-axis. And we can see that by moving up and down. You can see over here the y-axis changing value. So for an up, let's go ahead and say 70 on the y-axis. Save it out and see what happens now when we press space. Still nothing happening, so something is going wrong. Oh, and there we go, flying up into the air. One problem that we have here is that our get key down is asking for input, but we're asking for it in a fixed update. So this is why the get key down is only sometimes happening. In this case, I'm going to get rid of it just so that this works a bit more easily. There's another solution for it, but for now, we'll just use our get key. And we fly far too fast into the air. And that is because partly we are not at the moment checking if we're on the ground. We're just jumping regardless, which means that as long as I hold down the space bar, we'll be continually jumping, and that's why we shoot straight up into the air. Whoa, there we go. So in the next YouTube video, we'll be working out how we can do some collision detection. We're going to work out how we can prevent the character from jumping in the air unless they're colliding with the ground, unless they're on the ground. And then the other thing we're going to try and add is a collision with this lava that we made so that the character fails by hitting that lava and is destroyed.